All right, let's talk Java. If you've ever written an app, you've had to deal with data. But are you really using the right tool for the job? Today, we are opening up the Java Collections Framework. Think of it as the ultimate, definitive toolbox for handling data like a pro. Let's dive in. Every single application, I don't care if it's a tiny script or a huge enterprise system, has to store and shuffle around groups of objects. So the real question isn't if you'll manage data, it's how. How are you going to do it in a way that's fast, safe, and actually clean to read? And that right there is where this framework comes in. This isn't just some optional feature. It's a complete, super optimized, and seriously battle-tested set of data structures. It's like having a master mechanics toolbox that saves you from having to invent the wrench every single time you need to turn a bolt. So here's our game plan. We'll kick things off with the 3 core choices you're going to face all the time. Then we'll get more granular and talk about picking the specific tool for the job. After that, we'll look at some advanced power tools, cover the essential safety rules to avoid those nasty bugs, and we'll wrap it all up with some pro-level best practices that'll make your code just shine. Okay, this is it. This is the first and honestly the most critical decision you have to make. Getting this part right saves you from massive headaches down the road. So what are you dealing with? A list, a set, or a map? Let's break them down. First up, we've got the list. The 2 words you need to burn into your brain here are ordered and duplicates allowed. Just think of a to-do list, a music playlist, or people standing in line. The order is everything, and yeah, you can totally have the same song twice in a playlist. You get to items by their position, their index, like pulling a book from a numbered spot on a shelf. Next up is the set. And a set has one single unbreakable rule: uniqueness. No duplicates. Period. If you try to add something that's already in there, it just gets ignored. This is absolutely perfect for things like tracking unique user IDs or a bunch of tags on a blog post, or really any time you just need to know, is this thing in here or not? And finally, we have the map. A map is, for all intents and purposes, a dictionary. You have a unique key, which is like the word, and that key points to a value, which is its definition. A phone book is a great example. The name is the unique key, and the phone number is the value. The keys have to be unique, and they give you a blazing fast way to look up the value you need. So here it is, your cheat sheet. This little table boils it all down. If you need order and you're okay with duplicates, you want a list. If uniqueness is the only thing that matters, you need a set. And if you're looking stuff up using some kind of unique ID, it's a map. Seriously, commit this to memory. It's your fundamental guide. Okay, so you've made the big decision. List, set, or map? Awesome. Now it's time to pick the specific wrench from the toolbox. This is the next level of detail, because choosing the right implementation is what makes the difference between code that flies and code that crawls. When it comes to lists, your 2 main contenders are array list and linked list. Now, array list is your default, your go-to 99% of the time. Because it's just an array under the hood, grabbing an element by its index is ridiculously fast, what we call O1, or constant time. It doesn't matter if there are 10 items or 10 million, it takes the same amount of time. Linked list, on the other hand, is a specialist. It shines when you're constantly adding or removing things from the very beginning or the very end. That makes it perfect for building things like queues. With sets, your choice really comes down to whether or not you care about order. Hash set is the speed demon. It gives you that same O1 constant time performance for adding and checking if something exists. It cares about one thing: speed. It has 0 concept of order. But what if you do need to loop through things in the same order you put them in? Well, that's what linked hash set is for. And if you need your unique items to always be sorted, like for a high-score leaderboard, tree set has you covered. Its performance is O log n, which is still incredibly fast. It just means it gets a tiny bit slower as the set grows huge. Okay, now for a really cool pro-level trick. Linked hash map is a special kind of map that normally just remembers the order you inserted things. But look at step 1. If you create it with access orders set to true, you flip a switch that turns it into something amazing. Now, as you see in step 3, every time you get an item, it silently moves to the front of the line. Then, with one tiny method override, you get to step 4, automatic eviction. When the cache gets full, the least recently used item, the one you haven't touched in the longest time, just gets kicked out. It's an incredibly powerful cache in just a few lines of code. All right, we've used the standard tools. Now we're reaching for the power tools in the back of the toolbox. That LRU cache was a perfect example. But let's look at another huge problem. What happens when you have multiple threads all trying to mess with the same data at once? For that, you need collections built specifically for concurrency. For multi-threaded stuff, concurrent hash map is the absolute king. It's incredibly optimized for tons of threads reading and writing at the same time. Then you've got copy on write array list. This one's perfect for when you read way more than you write. Think a list of event listeners. And finally, blocking queue. This is the literal backbone of producer-consumer patterns, letting one thread safely hand off work to another without everything blowing up. Look, having the right tools is great, but knowing how to use them without cutting your hand off is even better. These next few rules are all about preventing those painful, hard-to-find bugs that can drive you crazy. Ah, yes, this one. If you've been doing Java for any amount of time, I guarantee you've seen this, and probably wanted to throw your monitor out the window. This exception is the classic sign that you've broken a really fundamental rule of collection safety. And here it is, the classic mistake that causes it. You cannot, I repeat, cannot modify a collection while you're looping over it with a standard for each loop. It's like trying to saw off the branch you're sitting on. The loop just gets totally confused and throws this exception to save you from weirder problems. The correct way, the safe way, is to use the iterator's very own remove method. That lets the iterators stay in control and safely take out the trash without losing its place. This one here is non-negotiable. It's basically the law. For any object you ever plan to put in a hash set or use as a key in a hash map, you must correctly implement equals and hash code. The contract is simple. If two objects are equal, they absolutely must have the same hash code. If you break this rule, your objects will basically get lost inside the collection. You'll put something in, you'll know it's there, but the collection won't be able to find it ever again. Okay, let's wrap this all up with a lightning round of best practices. These are the little habits that separate good code from truly great, professional, and robust Java code. First, always program to interfaces. Declare your variables as list, not array list. It means you can swap out the implementation later by changing just one line. Second, when you pass collections around, make them immutable. It prevents other parts of your code from messing with your data unexpectedly. Third, if you have multiple threads, just reach for the Java util.concurrent classes first. They perform way better than the old-school synchronized wrappers. And finally, use atomic operations like compute if absent. This prevents really nasty race conditions where two threads try to update a map at the exact same millisecond. So there you have it. The toolbox is open. We've seen the core tools, the power tools, and the critical safety rules. You now have the knowledge you need to pick exactly the right data structure for any job, making sure your code isn't just working, but that it's efficient and solid. The only question left is, what are you going to build with them?